Imagine floating in the vast silence of space, a realm where a single mistake can be catastrophic and where the unknown stretches endlessly in every direction. What if the key to navigating this immense, perilous environment isn't just human skill, but artificial intelligence? How is it possible that machines, which once existed only in labs and science fiction, are now becoming our partners in exploration, capable of analyzing millions of variables at once to keep astronauts safe and space missions on track? Space is unforgiving, a place where radiation, micrometeoroids, equipment malfunctions, and even tiny miscalculations can spell disaster. Yet AI is now learning to anticipate these dangers, to model the invisible forces that govern planetary motion, gravitational anomalies, and the subtle variations in cosmic radiation, all while making split-second decisions that could save lives. What does it mean for our understanding of risk when a machine can calculate probabilities faster and more accurately than the human mind, while still adapting to the unpredictable chaos of deep space? Consider the task of piloting a spacecraft through an asteroid field or around the intense gravitational pull of a gas giant. How do humans even begin to process all the variables in real time? AI doesn't just react, it predicts, simulates, and optimizes trajectories with an almost prescient understanding of physics. Neural networks trained on decades of orbital mechanics, satellite telemetry, and deep space imaging can identify potential hazards before they appear, adjusting thrusters, calculating fuel efficiency, and even reconfiguring mission priorities autonomously. What if a spacecraft's AI could communicate with other AI systems across hundreds of millions of kilometers, sharing data instantaneously, effectively creating a planetary nervous system guiding humanity through the cosmos? The implications are staggering. A collaborative, intelligent web of machines working in concert to expand our reach while minimizing risk. A network that sees and understands the invisible forces shaping our journey through space. Beyond navigation, AI is revolutionizing life support and human health monitoring. Astronauts face the challenges of microgravity, bone density loss, muscle atrophy, and immune system suppression. How can we track every subtle change in their physiology and intervene before it becomes a problem? Advanced AI systems now monitor biometrics in real time, predicting fatigue, nutrient deficiencies, or early signs of illness long before symptoms appear. Imagine an AI capable of synthesizing this data, suggesting personalized exercise regimens, dietary adjustments, or even recommending specific molecular therapies to maintain optimal health in the harshest environment imaginable. Could it be that soon humans in space will rely as much on AI caretakers as they do on fellow crew members, ensuring that long-duration missions to Mars or beyond are not only possible but safe and sustainable? The applications extend to robotic exploration as well. Rovers on Mars, probes in the asteroid belt, and autonomous spacecraft traveling to the outer planets are learning to make decisions independently, navigating terrains that no human could traverse in real time. How is it that a machine millions of kilometers away can detect subtle geological formations, analyze mineral compositions, and adjust its path without waiting for instructions from Earth? This isn't mere automation. It is the emergence of situational awareness in machines, an intelligence capable of interpreting environments, prioritizing objectives, and adapting to the unknown. What might this mean for future colonization efforts, where autonomous systems could prepare habitats, mine resources, and establish infrastructure before humans ever set foot on alien soil? Then there is the challenge of communication. Signals traveling across space are subject to delays of minutes or even hours. How can a mission respond effectively to immediate threats or unforeseen conditions when human guidance arrives too late? AI overcomes this by making decisions locally, based on complex simulations and predictive modeling. What if a spacecraft could anticipate a solar flare or a meteor shower, autonomously altering its shields, rerouting power, and even modifying scientific experiments to protect both crew and instruments? The idea that machines could act with foresight in environments that humans can't even directly observe reshapes our concept of presence and agency in space. Suddenly, distance is no longer the barrier it once was. AI extends human reach into realms we could never physically inhabit in real time. Artificial intelligence also allows us to see what is otherwise invisible. Sensors can detect cosmic radiation, magnetic field fluctuations, and minute gravitational variations, but humans cannot interpret this data fast enough to act on it in critical situations. AI transforms these invisible streams into actionable insight, translating complex patterns into decisions that optimize safety and mission outcomes. Imagine an AI network interpreting the invisible dance of celestial bodies, guiding spacecraft with precision that exceeds the limits of human perception. Could the future of exploration be defined not by how far we can physically travel, but by how effectively we can interpret and act on the invisible forces that govern the cosmos? Safety is not the only benefit. Efficiency and innovation also thrive when AI manages the complexity of space travel, planning optimal flight paths, energy management, payload logistics, and even predictive maintenance of engines and life support systems are now within the capabilities of intelligent systems. How is it possible that a single AI can balance hundreds of competing objectives, weighing risk, fuel, and time to arrive at an optimal solution in seconds, a process that would take human teams weeks of calculation and deliberation? This optimization extends to human-machine collaboration, where AI anticipates crew needs, adjusts schedules for peak cognitive performance, and even suggests contingency plans for every imaginable scenario. Could we one day see fully autonomous base stations, where AI orchestrates every task with an intelligence that complements human curiosity, creativity, and problem-solving? In deep space, where unforeseen events are inevitable, the combination of AI and quantum computing becomes particularly powerful. Quantum systems can simulate complex orbital mechanics, radiation interactions, and fluid dynamics at scales impossible for classical computers. What if AI could harness quantum computation to model billions of possible outcomes, testing scenarios in virtual reality before any physical action is taken? The result is not only safer travel but also accelerated discovery, as spacecraft autonomously conduct experiments, analyze results, and iterate designs without waiting for human direction. Could AI eventually surpass human capability in both exploration and scientific insight, creating a partnership where humans provide imagination and ethical guidance, while machines execute with precision and speed beyond our comprehension? Space AI also transforms emergency response. Consider a catastrophic system failure or unexpected collision. Traditionally, human reaction times and remote guidance introduce critical delays. Now, AI can immediately assess damage, isolate failing systems, reroute power, and stabilize life support, all while alerting crew members and ground control. How might this instantaneous problem-solving change our approach to risk, mission planning, and even insurance for space travel? With AI acting as an intelligent co-pilot, humanity can venture further and bolder than ever before, confident that our creations are capable of protecting us when the unknown strikes. Beyond safety and logistics, AI is also unlocking the secrets of the cosmos. Autonomous instruments are detecting exoplanets, analyzing atmospheric compositions, and even searching for biosignatures on distant worlds. How is it that machines can process astronomical datasets faster than entire teams of scientists, identifying subtle signals buried in noise that would otherwise be invisible? This capacity transforms exploration from passive observation to proactive discovery, enabling missions that not only survive in space, but also expand our knowledge at unprecedented rates. Could AI eventually become the primary explorer of the universe, preparing the way for human arrival with insight and precision we cannot achieve alone? Philosophically, the integration of AI in space travel challenges our understanding of human presence. What does it mean to explore when machines are thinking, deciding, and acting independently in environments beyond our direct perception? Are we still explorers, or are we now creators of intelligent partners that extend our reach into realms we can only imagine? The boundary between human and machine blurs as AI becomes both tool and companion, capable of learning, adapting, and even anticipating human needs in ways that redefine what it means to participate in the cosmos. Could the ultimate frontier of exploration be not the distant stars themselves, but the evolving intelligence we share with the machines we send to meet them? As AI continues to evolve, the possibilities grow exponentially, from autonomous piloting and life support management to scientific experimentation, hazard detection, and predictive maintenance. Intelligent systems are creating a safer, smarter, and more adaptive spacefaring future. How might humanity change when our survival in the most extreme environments depends on a partnership with intelligence that is not bound by our biological limitations? Could we reach destinations and perform discoveries that would have been impossible a few decades ago, all because our machines think, plan, and respond in real time to the complexities of the cosmos? The future of space travel is no longer simply about rockets, propulsion, or human endurance. It is about intelligence, both human and artificial, working together to push the boundaries of what is possible in the vast, uncharted universe.